I am Revati, Assistant Professor, Department of EEE, SNS College of Technology. In this lecture series video of Fundamentals of Electrical and Electronics Engineering, today's topic is construction of DC generator. So, talking about the construction of DC generator, the electrical machines combinedly called as DC generator and DC motor, which has the same in construction, so that it's mainly based on the principle which is act like a generator or else it's act like a DC motor. So let us discuss about electrical machines. It is in two classifications. First one is static machines and another one is dynamic machines. So static machines is a transformer, and which comes under dynamic machine is generators and motors. Why? Because transformer is a static device. It doesn't have any rotating part, whereas in generator and motor, a rotor is a rotating part present, whereas in stationary part is your stator. So without any rotating part, one state of energy is converted into another form of energy only in transformer, so that is known as a static devices. So what are all the topics we are going to discuss about is classification of electrical machines, types of machines, construction of DC machines, major components. So identify the various form of natural energy sources available. So firstly, I have discussed that electrical machines is based on energy conversion system, so that there are two types of energy which are majorly considered for electrical machines. One is electrical energy and another one is mechanical energy. So there is two types of energy conversion takes place, whereas in electrical energy which is converted into mechanical energy, then the machine act as a motor, whereas in mechanical energy which is converted into electrical energy, the device act as a generator. So whereas in another form, one type of electrical energy is converted into another form of electrical energy. So electrical energy is converted into electrical energy that works as a transformer. So what are all the natural energies available are wind, tide, and force, etc. are some of the energies. So classification of electrical machines is static and rotating machines. So static we have already discussed, that is transformer. Rotating machines is DC machines or AC machines. So in DC machines, there are two classification, DC generator and DC motor. In AC machines, there are further classified into two types, synchronous machine and asynchronous machines. So DC machines have these two classifications only, but else in AC machines, synchronous generator is further classified into two types, which is synchronous generator, synchronous motor, where asynchronous generator is further classified into one type, that is induction motor. So that in induction motor, that is further classified into two types. One is single phase induction motor, another one is three phase induction motor. Whereas in synchronous machine, synchronous generator is classified into single phase and three phase synchronous generator. And synchronous motor is further classified into two types, that is single phase synchronous motor and three phase synchronous motor. So types of electrical machines are transformer, generator and motor. Majorly this is classified into three types. So electrical transformer, both input and outputs are electrical power. In electrical generator, input is mechanical power and output is electrical power. In electrical motor, in motor, input is electrical power and output is mechanical power. So major components of electrical machines are stator and rotor. The stator consists of yoke or frame, pole core and pole shoes, field poles, field winding and interpoles. So in stator, yoke act as the outermost layer of the machine, which protect the device from damages, dust and any other external invaders. So pole cores are pole shoes, act as a supporting for a field winding. In rotor, armature core, commutator, brushes are the major components of electrical machines. So this is the construction of an electrical machines, whereas poles are present, north and south pole. So the poles are supported by the pole shoe. Commutator segments are circularly arranged in a segment. Shaft is present inside the commutator. Interpoles, frame of yoke is present in the outermost layer, and field winding supports the wounded on the poles. So various part of DC machines, yoke act as a frame of the machine, mechanical support, and for small machines, cast iron is used. For larger amount of machines, cast steel is used. So pole shoes are laminated to reduce heat losses, fitted to yoke through bolts, act as supports to field poles and spread out. So field coils are magnetizing coil, excited coils, provided excitations, that is EMF induced in the field fluxes. So in pole core, carry the field coils, rectangular cross-sectional areas. So in armature core, it is cylindrical or drum shaped. It is built. High grade silicon steels are used to reduce hysteresis loss and eddy current losses. So hysteresis loss is your BH curve. To rotate conductor in a magnetic field, high grade silicon steels are used to reduce the types of losses which are occurs in an armature core. Whereas in armature winding, it is made up of copper or aluminium. Why copper or aluminium is, these two things are the major conducting material. It's a good conductor, so that we are selecting copper and aluminium. Winders are insulated from each other, so touching of uninsulated material causes circuit to be shorted, so that proper insulated from each other is required. So commutator is present between armature and external circuit. Split ring act as a rectifier AC to DC. If you are creating an circuit in an AC supply, whereas you needed the output is in DC supply, so that we are using a split ring. Commutator drawn copper bar segments insulated from each other by a mica segments. So bearing and brushes are used for shaft and bearing is a mechanical link between prime mover and armature. So prime mover is a thing which we are used to rotate the device for a mechanical support. Bearing is for a free rotation. Brushes and brush gears are carbon graphite, copper used to collect current from commutators. So armature winding consists of lap winding and wave winding. The windings are connected in parallel, which is known as lap winding, which is connected in series are known as wave winding. Lap windings used for designing of low voltage and high current. In whereas in wave winding is decided for high voltage and low current. So these are all the images which we have seen in the previous slides. So first one is yoke, and second one is pole shoes and all those things. Third one is shaft or bearing. Fourth one is your split ring, and fifth one is your split face. So construction wise, mechanical part and electrical part. So mechanical part is your yoke, bearing and shaft. Magnetic field systems are poles and field winding. Mechanical electrical part is your armature core, armature winding, commutator, brushes are the basic construction of a DC motor. So if the curiosity challenges, so the assessment part is, if the yoke is made up of non-metallic material, what happened to the generator performance? So hints are given below: low generated EMF and poor efficiency. Imagine you are asked to design a mini DC generator using a bicycle dynamo. Which part corresponded to the armature and field winding? So quiz: the component which converts AC to DC in a DC generator is the commutator. So which part of a DC generator rotates? So obviously we know that armature is the part which is rotates in the DC generator. So these are all the reference links. So go through it. Thank you.